A second. All right, there we go. It looks like we're recording now. All right, here we go. Smart, no more. All right, here we go. Let's talk about this word. Oops. Oh, I forgot to do this. I always forget. I've done this for years, and I always forget to change my pen settings. There we go. Now it should work. So let's do this word, coordinate. You guys had Algebra 1 last year, right? Yeah. You probably talked about a coordinate plane. Did you talk about a coordinate plane? Yeah. Did you graph X and Y's and all that stuff? Yep. Yeah. So you probably talked about this word, coordinate. So this shouldn't be very difficult. We're going to go real easy right now. We're not even going to do an X and a Y. We're just going to do one horizontal plane. That's it. So basically it's a number line. Well, a coordinate isn't a number line, but we use a number line to talk about a coordinate. So basically a coordinate, I'm not going to write it down just for the sake of time, but I'll just say it. A coordinate is a point on the number line that corresponds to that point. Okay? So it's a point on the number line. Just because you have a point doesn't mean that there's a number associated with it. Right? We've done a lot, haven't we? So like if I call this point A and point B, right? There's a point on the number line, but do I have any idea right now what the number associated with it is? No, I have no idea. All right, but I can put a letter, and I could describe or I could name the point, but this time we're actually going to put some numbers. So I'll tell you what, let's get rid of the dots as well. All right, so we usually put the numbers 3, 2, 1, 0, 1, 2. All right, that's good enough right there. Let's say that's -3, that's -2, it's -1, 0, 1, 2, and let's put a 3 in there just to even it up a little bit. Everybody with me so far? All right, yeah, it's easy. You've seen that a million times. What we're going to do is put some points on here. Put a point right there. Put a point right here and right here. So when we talk about the coordinate of the point, it's A, B, and C. So what's the name of this point right here? This very first point that I'm kind of hovering around right here. What's the name of that point? It's point A, that's right. We don't call it -2. We don't call it point -2, all right? That's not what we call it. We call it point A, but what's the number that's associated or corresponds to that point? It's -2. So this is called the what? The coordinate of point A. So if I asked you, what is the coordinate of point A, what would you tell me? It's -2. Yeah, simple, right? The next two questions, you know exactly what I'm going to ask, don't you? What's the coordinate of point B? Okay, it'd be 0. What's the next question I would ask? What is the coordinate of point C? That's right. What's the coordinate of point C? It's 1. Okay, so that's pretty simple. So we started off really easy. All right, no biggie on that one. Let's talk about the length. Now, you probably know how to find the length of something. If you had a tape measure, a ruler, a meter stick, or something like that, you could probably find the length of something. Okay? So what if I asked you, let's everybody look up here, pay attention. Stop all the little comments. So if I asked you the length of AB with that little symbol, what is that thing right there? Line segment. And in fact, the name of this lesson is what? Segment and angle measure. We're not doing the angle just yet. We will eventually, but let's do the segment right now. Okay, so the length of segment AB. Now, what does that mean? What are we referring to when we're finding the length of it? How far it is. That's good. I like that. How far it is from A to B. All right, so that little bit right there would be the length of AB. Agreed? How can we find that if we have a little number line? Could just count, couldn't you? Each one of these little dashes are a 1. So if we start here, let's count. What do we got? 1, 2. All right. Doesn't mean we're at point 2, does it? Or at the point where 2 is. Okay. It just means there's 2 spaces. Okay. It could be in centimeters. It could be millimeters. It could be miles. It could be yards. Whatever. It could be kilometers. All right. But the length of it is 2. Isn't it? Yeah, it doesn't matter. If they don't give it to you in centimeters or meters, you just write the number. Yep. But it's a good question because there will be a time where we do some stuff and you do have the measurements on there and you do need to put the measurement on there, okay? Every math teacher makes you do it, don't they? Yep. Okay. Because it's important. Because 2 inches is a lot different than 2 miles. Would you agree? Yeah, so it's important that you say how many. But this, there's no units of measurement on this so far. You just say it's 2. Just say it's 2. So what's the length of AB? Line segment AB? It's 2. Now, let me show you this. In geometry, as you've seen already, we have all kinds of different ways to label things. So when I talk about the length of, now this, for some people they get confused. It's a very subtle difference. It's a very subtle difference. Xavier, are you with us? Okay, get your head up, off your hand, and pay attention. Your pencil should be in that hand, all right? If your pencil's in that hand, then you won't sleep on that hand because you'll be jabbing yourself in the face with your pencil, all right? So that's a good way to stay awake. All right, here we go. The length of AB, this is the way that we describe it. We just put an AB with nothing over top of it. You follow me on that? What does this mean right here? This means right here, I'll put it in quotes because this is what we would say. You would say that this is the what? The length of line segment AB. Okay, that's what this means right here. When you have an AB next to each other, or any 2 capital letters next to each other, and there's nothing on top, there's no line symbol, there's no line segment symbol, there's no ray, nothing's on top of it. It's just a capital letter and another capital letter. Automatically, that means we are finding the what? The length of. So, what if I just said AB equals, and then put a blank right there? What would you tell me? 2. That's right, because that means the length of line segment AB. We got to be on the same page, all right? It's like learning a new language, right? You're learning vocab, right? Just so you know what the words mean, and now we put them together. So that's what this means right here. The length of line segment AB, it's 2. How did we find it? Well, we just counted, didn't we? But let's do it a little bit more mathematically, okay, to find the length of AB. Look at it. I went from -2 to 0, correct? And I just counted. That was easy. But there's a little better way, because what if I was like at -273 and I was going up to 358? Am I going to draw a number line and put all those little dashes on there? That would be crazy, and then count them all. Would you agree? Do you? In this case, that would work, but not in every case. What if I wanted to find, let's do this. We already know AB, right? Since you brought that up, I hadn't thought about that, so I'm glad you said that. What if I asked you to find AC? What does that mean? If I just put find AC, what are you looking for? Finding the length of AC. All right, now you could just count. Let's do that. Start at A, or you could start at C. Doesn't make any difference. Let's count. 1, 2, 3. Okay? Now, do you add them to get that length? No, because what's -2 plus 1? It's -1. So the length of this is not -1, is it? What is it? It's 3. So what math did we do to get AC? And we do the same math to get AB, but AC makes a little more different, or it makes more sense, because to get to AB, I could either add it and I still get 2, or subtract and I still get 2. But what am I going to do? Am I going to add? No. What do I do to this number and this number to get a 3?
Add the difference.
Add the difference?
Yeah, so you subtract.
How about just say subtract? That's better than add the difference, right? Or find the difference. You could say that. I wouldn't say add the difference. Just subtract. So now watch this. Doesn't matter what order I subtract them in. Because length is always what? Like if I had a tape measure and I was to measure the length of this wall right here, and it's, 25 feet, okay? And I think it is pretty close, maybe 30 feet, something like that. If I measured it and said 30 feet, okay, would I ever say, well, let's measure it the other way, and I would get -30 feet? Would I ever refer to the length of that as negative? No. Length is always what? Positive, okay? So even though -2 minus 1 is -3, I still use the positive. I don't use the negative. And the way that we show that in math is to put it in, what are these things going to be? Absolute value. That's right. Because the absolute value of anything is always the what? Always the positive version of it, okay? So what math did I do? Negative 2 minus 1. So what's the absolute value? Well, first of all, what's negative 2 minus 1? It's negative 3, but it's inside absolute value, so that gives me what? A 3. Or, I could put an or right here. I could subtract the other way. I don't have to go the first one minus the second one. I could go the second one minus the first one. So let's do it that way. What's this going to be? Well, no, let's start with this one. 1 minus, not 1 minus 2. What is this? This is a negative 2. So it's 1 minus what? Yeah, and that'll be 1 plus 2, which is the absolute value of positive 3. What's the absolute value of positive 3? It's just 3. Okay? So basically, all you need to know, sometimes people get all worried about the absolute value thing because it looks a little tricky and all that stuff. But really, what does the absolute value just do to it? It just makes it what? Positive. That's it. Okay? So it doesn't matter what order we subtract these in. Doesn't matter at all. As long as you put it in absolute value, make sure our answer just comes out positive. Okay, that's the only reason we put the absolute value there. It's not to scare you. It's not to make it look real complicated. It just shows you that we take the positive version of the answer, and it doesn't matter which way we subtract. Yeah, but if I, what if I added that?
Well, no,
See?
like if I take the 2 and I put it in those, what are those brackets called?
Absolute value.
And put it in absolute value.
Yeah, let's not do that. We always put the numbers in the way they are. No, I think it'd be more work the other way. Because look, what is AC? It's negative 2 minus 1. That's negative 3. Make it positive 3. But then you're thinking, okay, let's make that a positive. It just gets too confusing. Just subtract them, because then we got the same rule all the time. You always subtract. Okay, to find the length of a line segment, always subtract. You got it? So, I mean, what if I found, let's just make it super easy. Let's put a point here, and let's call this D. What if I wanted to find CD, or the length of CD? What do? I don't add them. What do? Subtract them. Does it matter what order we subtract them in? No. I think it's a little better to take the bigger one minus a smaller one, because then you'll always get a positive. You don't have to worry about changing the sign of it. All right, but it works either way. Watch. It could be what? 1 minus 3, right? Which is what? Negative 2. But it's an absolute value, so we always take the positive version. Or we could just do what? 3 minus 1. That comes out to a positive 2, and your absolute value. And it's already positive, so there you go. Does that make sense? So what if I had a big number? Like you had a big old number. I won't go like the negative 200 and something I said, but what if this was like negative 17? And what if you had a point way out here that was 32? All right. What would you do? You could do that, but what I think is a little bit easier, and you're absolutely right, you could do that. All right, but what I think is a little easier, so it always stays positive, is take the bigger one minus what? The smaller one. No, don't add. Just think subtraction. All right, so it's 32, and I know what you're getting at, but I don't even want you to say add, all right, until you write it down. So it's minus what? Not 17, but negative 17. So now you can say it, Noah. This turns into what? A plus, and that's what? 49? That's a lot better, wouldn't you agree, than making a number line, going all the way down to negative 17, and then going all the way up to 32, and then counting them all in between. That would be crazy to do that every single time. So we need to learn a little mathematical way of doing things. All right. Everybody good with that? Yeah, it's pretty easy. You just subtract. What are some other things? Let's see. I think we found pretty much all the lengths, didn't we, between these points, right? A to B. We found A to C. What about B to C? What's that? It's just 1. You can just look at it and count, right? But you got a 1 and a 0. 1 minus 0 is 1. All right, you got it? Let's go from the ends. It's not technically the ends because it's a line. It keeps on going forever. But as far as this one is concerned, we got -3 and +3. How far is that?
6.
It's 6. Okay, you could just count, or you could go 3 minus -3. Minus negative is plus. 3 plus 3 is 6. Okay? And that's all you got to do. But don't think add, because then you're going to go from, what is it, from -3 to -1? If you think add, you know what you're going to do? You're going to make a mistake and say -3 plus -1. I'm telling you, listen to me. You could say it's okay to do your way all the time, but I'm telling you, I know what could happen. Think subtract. How do you find the length? You do what? Subtract. Don't think add, think subtract. All right. Let's do something else. Let's talk about, this is the first time we talked about this word, and we're going to be saying this word over and over and over again the whole entire year. So you must be excited to hear what that word is, aren't you? Did you hear what I said? We're going to be saying this word over and over again in geometry all the time. Here it is. Now, no guessing. You won't guess.
Congruent.
Right, congruent. So in geometry, congruent kind of means equal to each other. Kind of. All right? It's got a lot of similarities to it. But technically, it doesn't really mean equal. But sometimes I use it simultaneous. Or not simultaneous, but what's the word? I use them together. I don't know. I'm trying to think of a word. I can't think of it. So what we're going to do is talk about congruent interchangeably. That's a good way to say it. Congruent segments. Okay, we know what a segment is already. What does it mean to be a congruent segment? Well, with my nice little program, watch what I can do. I could copy it, and then I can what? Paste it. And then I can even change like the direction of it. So I copied and pasted. So tell me something that's true about both of these lengths right here. They're what? Well, I gave you a new word. They're equal in length. Okay, that's good. That's perfect. What you said, equal in length, that's exactly what I want to hear, okay? They are equal in length. So let's just make this up. Let's say I made that 5, whatever, inches, centimeters. Doesn't make any difference. I just made it 5, okay? And this is the exact same thing because I copied and pasted. So that's 5. So if these two segments have the same length, what could we say about these two segments? Then they are parallel? Never even used that word yet. We haven't even talked about that word. The word's right here. Congruent. That's right. They're congruent. And they definitely don't look parallel to me. All right, so we're not using parallel. We eventually will. We're going to use parallel so many times you're going to be sick of hearing about parallel. So we will use parallel a lot. Same with congruent. But we would say that these are congruent segments. So watch this. Let's put a dot here and a dot here, and a dot. Not dots, they're points. Shouldn't say dot. So let's go A, B. Let's go C, D. Okay? So if I say they're congruent segments, we have a little symbol for congruent. You know what an equals looks like, right? And then what? That's ugly equals. Equal. And then we put a little squiggly. Oh, that's a terrible squiggle. Like that. Good. Check the YouTube. All right, and you got the assignment from there. All right, that is the symbol right there. That's the symbol for congruent. It's an equal sign with a little squiggly on the top. That's what congruent means. So if I said that they have the same length, this has length 5, this has length 5. Here's another way I could show length. I'll do this in a different color. Use this nice blue. And you're going to be doing this forever in geometry, okay? If I put a little, we call that a tick mark. If I put one little mark here and one little mark here, that means that those, let's say I didn't even know that they're 5, the length of it is 5. If I put a little tick mark here and a little tick mark here, that automatically means the lengths of those two segments are equal to each other. Which means if the lengths are equal to each other, then what's true about the segments? They are what? Congruent. So let's show you how to write congruent. So this segment, what am I going to call this segment right here? AB. Now it's a line segment, so what do I have to do? Put the line over top of it, okay? Is congruent to, what's the symbol for congruent? Equals with a squiggle, all right? So it's congruent to what over here? line segment CD. Okay? That's how you show that things are congruent to each other, right? If you got this little tick mark here and here, that means they have the same length. That's what the tick mark means, okay? And then that means that if they have the same length, then those are congruent to each other, and that's how we would show that they are congruent to each other. Everybody with me? Yeah. I mean, it's simple stuff, but I'm telling you, we're going to be using this so much, you just wouldn't believe it. All right. We haven't done any like real math in here yet, have we? Well, we did a little bit today. We did the minus and the plus, but let's do some math. So I don't know which one was example 1. What was example 1? I don't know. I think I might have skipped example 1. Let's talk about this real quick. Let's talk about being between. We talked about that before, didn't we? Because I read some questions or read some problems from your homework that talked about between, but let's do this. Put an A here, put a B right there, and put a C right here. Okay? What do we know about B? I already kind of gave it away. What do I know about point B and A and C, the relationship between them? It's between. That's right. B is between because they are collinear, correct? So if I have one point on one side of B and another point on the other side, then B must be between those 2 points because they're on the same line. That means that if I added up the length of AB, notice I didn't put a little segment over top of it. I'm talking about the length. When I talk about the length, I'm talking about a number. It could be 2 centimeters, it could be 7 meters, it could be whatever, right? There's a number associated with it when I say the length of, plus the length of BC, very good, equals the length of what? AC. Does everybody see that? So if I knew what the length of that was, and I knew what the length of this one was, and I added them together, then I got the length of this whole entire thing. Makes sense, doesn't it? Let's just stick some numbers in. Let's say that's 5. Let's say that's 2. So AB is 5, BC is 2. What is AC? It's 7. Easy, right? Yeah. Now, here's where we do our first algebra of the year. This is example 2. And this is what we do in geometry, just so you know. We learn some geometry principles and we see how it relates and how math and algebra is used to solve for some missing parts, right? So, for instance, we'll use that same ABC. Got to do this quick. This will probably be the last thing we do today. Let's see. So we'll do it again. So that's A, this is B, and this is C. All right? But this time the question says, find AB, the length of AB, and the length of BC if, and I got to put something else in here, AC is equal to 75. Now here's something else I put in here. They say the length of AB, they don't give you an actual number like we did the 5 and the 2, right? They give you a little bit of things with some variables. And this is 5x plus 10. It may not be to scale, by the way. All right. Here we go. This is our first real geometry problem. Okay, you've had a couple homeworks already, but this to me is like the first thing that we're going to do, that we're going to do a lot of this kind of stuff later on in the year. So this is it. So watch, find AB and BC. So I'm trying to find that length and that length. If AC is 75, which means what? The whole entire thing is what? Is 75. So what do I do to this length and this length to get it to be 75? You just add them up. Remember we had the 5 and the 2 and it was 7, right? It's the same thing. This is kind of like my 5, this is kind of like my 2, and that's kind of like my 7. Okay? So we take this little chunk, add them together, you got the whole thing. Everybody seeing that? Yeah. All right. So how do we write this down? 6x minus 1. I got to go kind of quick because bell's about to ring. So 6x minus 1 plus what? 5x plus 10, right? So that's the one segment. That's the other segment. If you add them up, what do you get? 75. Now, I'm going to do this kind of quick. Again, like I said, because of the time right now, I've got like 3 minutes left. So in algebra, we add like terms. Remember that? So 6x plus 5x is 11x. Okay, and then we got negative 1 plus 10. What's that? Plus 9. That equals 75. See how your algebra helps you out with this stuff? Let's get x by itself. What do we have to get rid of first?
Divide by 11.
Not yet. No. Yeah, you get rid of what's being added or subtracted first. So you get rid of the 9. So since it's plus, you get rid of it by minusing a 9. Subtract a 9. And that would be, what is that? 66?
That's
Okay. 66. And now we can do what? Now we can divide by 11 since it's being multiplied. So what's x equal to? Is that my answer though?
no.
Because they want you to find what A, B, and B, C is. Say it. Zanaya, you said it. You got to do what to it? Plug it back in. Good. That's what I say all the time. A lot of math teachers say that. So x is 6, but I want to find what AB is. So what is AB? AB is 6x minus 1. So show your work. See everything I'm doing? All the work? You got to do the same thing. So what is this? 6 times 6 minus 1. 6 times 6 is 36. Minus 1 is 35. So AB, the length of AB, is equal to 35. Now you could do the same thing with BC, but there's a little bit of an easier way to do it. Now you know what this length is. You know the length of that is 35. What's an easy way to find BC? That's it. I would go 75 minus 35. And that's what BC would be equal to. All right, and what is that? And there you go. So there's that answer, and there's that answer. It is. If you like that stuff, you're going to love geometry, all right? Because that right there kind of tells you what you're in for the rest of the year. If you hated this stuff, sorry, but we'll try to get you to like it eventually. All right, you know what your homework is? It's on your lesson plans, right? I'll write it up here just in case somebody on the YouTubes needs to see it. So it's section 1.5. Now, we just did a little part of it. We didn't do the whole entire thing. So hopefully, you should be able to do up to 1 to 14. If you can't do up to 1 to 14, do as much as you can, okay? So it's page 27, and it's 1 to 14. I just stopped here because that's when the bell rang, so I'm not sure what they cover on 1 to 14. Do as much as you can. My feeling is you should be able to do most of them. Everybody good with that? All right.